All right, so in our contents slash sites PowerPoints, should be an and in there, shouldn't there? Folder, we have our PowerPoints. The first one was over preprocessor. Some extra stuff tacked on at the end, I think, but we're not going to use that because we reiterated it mostly in the second. As always, I recommend downloading the PowerPoint rather than waiting, depending on the preview function. And we can be pretty sure we're going to need C, so I'm going to go ahead and just launch Visual Studio in the background. All right. So ultimately, in C and in any language, it's composed of elements called tokens. That's what your source code is. A token is missing one of my slides. A token is the smallest unit of information that can be in a source code. And they're composed of different things. There are symbols. A plus sign is its own token. There are keywords. Float. Now in this case, F is not a token, but the whole word float is. There are identifiers. When you make your own identifiers. Variable names. X1, X2, X3, and so on. Each variable name is its own token. Each function name you create is its own token. I'm getting worried I uploaded the wrong one. All right. All right. If we go to slide 36, apparently I added a whole bunch of stuff or didn't remove stuff. I need to modify the PowerPoint correctly. So a token is an atomic unit. What do tokens mean? Well, when the program is compiled, it's creating a structure, an internal model inside of itself that will eventually be turned to object code, machine language. And so it's got to chop it up, divvy it up correctly. So the simplest element would be a single character or a group of characters called C tokens. Now what did I mean by single character? A quote around a letter and then an end quote. That is a token. It's about the shortest one you can come up with besides just a flat out semicolon, which could be used as a command because it means nothing before the semicolon. So the compiler does not break down the tokens any further. An open brace, close brace, parentheses, those are all tokens. So, several different types of tokens. We could have keywords. Float, int, double, while, for. You can have identifiers. Identifiers are your variable names, your function names, your self-made data types, your structures. Constants. Numeric constants, character constants. Strings. Not a string data type, but a string embedded in your code. Begins with a double quote, whereas a character begins with a single quote. If you have a single quote, you better only have one letter there, or at most an escape sequence, which is a slash followed by another letter, right? But a string can be empty string, nothing between it, or it can be long. What it really is it's just an array of chars, C-H-A-R, behind the scenes. And so our special symbols, we know what to use parentheses for whenever you invoke a function or you're trying to specify the order in which things are being processed in a mathematical operation, like 1 plus parentheses 2 times 3. Square braces are used to denote elements in an array. Curly braces block off your code. And then you have your operators. Plus, times, minus, that kind of thing. Do we have this slide twice? Nope. Click to add title. Alrighty. So, everything you write is going to be part of the C character set. Uppercase letters A through Z, the lowercase letters A through Z, decimal digits, certain special characters are allowed. Anything that's not on this list is probably not allowed. If you're going to be giving variable names in letters other than English, you're kind of on your own. I think that I proved that we can do that, but pretty much you can generically assume that English letters are a good thing to use. The program is case sensitive. C language is case sensitive. So if you name a variable, age, all lowercase, and an age with an uppercase A, that works. And then we have our special characters. We can give them names. Tilde. Kind of forget what tilde is used for. Commas, periods, semicolons. Anything of these is punctuation that the program uses and not things that can be part of an identifier. You can't make a variable name that has a period in it or a question mark in it, and colon, and double quote, single quote, left parentheses. Left brackets, right brackets, and so on. Slash and backslash. Less than, greater than, equal to. Exclamation mark, exclamatory mark. A lot of people just say bang. I didn't make that up. But if you say, bang 34, you would type in not, or exclamation mark 34. Also, that gets called not a lot of times, just because like not equal, exclamation mark equal, then you can use that, you can say that as not. And if I'm typing in code and I say not equal, then you're really supposed to type in that thing. Another silly name that you'll hear is at the asterisk, usually called star. Some people think it's cool to call it splat. And so if you had exclamation mark followed by an asterisk, bang, splat. Kind of silly. Okay, the hash. Been calling it hashtag, £, right? The British call it octothorpe, just to be weird. We know what a $sign is. We know what an ampersand is. May not know what it's used for in the language. We know what asterisks are, used in a couple of different ways. Some of these things have more than one meaning, and it's up to the compiler to parse it correctly based on, the placement of the tokens as to what the asterisk means. If you have two numbers by each other, asterisk means multiply them. If it precedes a variable name, it means a pointer. Caret, underscore. Only certain one of these are allowed in identifiers, specifically underscore. And honestly, I think $sign works, but I don't think it's standard. So generally when we use our identifiers, we're going to use underscores, but other than that, all letters, all numbers. So identifiers, they have distinct names, or they are distinct names. These are the things that we get to create. We don't get to define the words for and if, while, and things like that. But, we have data that we're tracking, and we have functions that we're writing, and we have types that we are creating, structures, kind of like classes in our other languages. So the identifiers are the distinct names given to program elements. Constants can be an identifier. You could also have a literal embedded in your code, just like the number 1, 2, 3. If you just stick that in there, x equals 1, 2, 3, that's a literal. But if you somewhere up above you say const int equals, or const int limit equals 1, 2, 3, and then later on you say x equals limit, then you're using a constant. Variables, functions. So an identifier is a sequence of letters, digits, and special key, one special character allowed, the underscore, with some rules. And these rules are the same as in the other languages you've used, most likely. Has to start with a letter or an underscore. No commas, no blanks, no other special characters. Uppercase and lowercase letters are treated as distinct. They are case sensitive. Okay. An identifier can be of any length. I don't know if there's a limit or not. Old versions of C would only allow variable names of up to 8 characters. And you could create them longer than that, but only the first 8 counted. I don't know if you could create an identifier that was, 170 characters long. And I don't know why you would want to do that. Generally, your rules are the longer the variable name, the more readable your variable name, the more information it imparts, the more useful it is as an identifier. Single letter variable names are lousy, but we use them for counters, right? 1, 2, 3, 4, 5. And in here, when I'm just demonstrating some concept, like making a mathematical formula, I'll probably also use single letter variable names. And no special symbol can be a variable name. Are there other rules? Didn't mention it, but they can't be keywords. You can't name your variable, for or if.
I think that's what it says on the next screen.
Well, that'd be good. Sort of.
Oh, well.
Yeah. Anyways, they have special meaning to the compiler. They can only be used for their intended action. Now, that doesn't mean you can't start a variable with the word if. You can pack some other, letters and numbers on after it. But generally, you're trying to make your code as readable as possible, so you wouldn't throw in reserved word-looking things. And you can get snarky with your variable names. For example, you can mix up lowercase l's and 1s. What's another one? Things that are hard to read. Zeros and capital O's. You really want to drive somebody crazy, name your variables things like O1 and 0L, like that, and then use them indiscriminately through your program so that they're almost impossible to figure out which is which. You're not going to do that, but you could. If your goal is to infuriate your coworkers, you could do stuff like that. When I'm up here and I'm typing stuff, I try to avoid lowercase l as a variable name just because it looks like a 1, and invariably somebody will type in a 1 where I meant a lowercase l. So keywords have special meaning to the compiler. They can only be used for that one intended action. They cannot be used for any other purpose, which is occasionally a drag. It's not like most of these words have a meaning that we'd really want to use. It's not as bad as in Python where you have a whole bunch of functions and it's a real drag that you can't call your own function max because that's a predefined keyword, or you can't make your own variable called max or things like that, length, things like that. The list of keywords for this is less than half of the list of keywords for C++. If you've taken C++, you already know the vast majority of these. We hit a page on the reading a chapter about these because I remember us talking about register. It's asking the code to keep that variable on a register for fast access. Volatile means that something outside the code could change that variable, or you could have multiple threads of execution that are changing that variable. And so it's saying you better double check that. You can't just cache it in a register, right? You better go out to that memory address and check it every single time. We've seen auto. Auto lets you declare a variable without giving it a type. Continue and break are part of loops. If you've taken C++ or Java, you're familiar with how those work. Maybe even Python. Enum sets up, well, we'll get there. We'll talk with these over. Short, int, and long are integer data types. Now there are standards for how long they are. And I think that most of the compilers are now abiding by the idea that an int is 4 bytes wide and then a long is 8 bytes wide. However, C++ treats an int and a long as though they are the same type. And then long, the words long, is the 8-byte data type. Now, I don't think that that's true for C++, but that would mean, for C, but that would mean that the same compiler is treating the word long in 2 different ways. We'll have to play with that. We'll have to see. We could print the size of, each variable type and find out what it means, or what its size is. Why don't we do that? Going to make a new project. Never just do new file, or else when you try to run it, the button that says debug will just say attach, and it's not cool. So new project. We don't want a Win32 console application. Please make sure it says empty project. June 11. Now I'm going to go to the Solution Explorer and create a new source file. Wednesday I'm going to try to get us in the other room. So when you come in, see if the other room is open. And I'm hoping that we can get in there and we can start playing with the command prompt with using cit2093 and compiling things by hand. So anyways, add new item. Don't make it as, I mean, you could click that, but what we really want is a .c file, not a .cpp. And you could give it a far better name than source. Well, in this case, June 11 strikes me as a good file name. So down here, I'm typing in june11.c. And just kind of eyeball your path. If your path has the word admin in it, then it's not going to let you create that. As a matter of fact, probably prior step, you know, if you're looking at the location and it said admin, then you're out of luck and you need to create a, another directory. I know you were having that problem. I hope you're doing okay today. All right. Alrighty. Forgive me for totally cheating. Standard IO.h, standard lib.h. We're probably going to disable the warning. I'm just going to grab that stuff and paste it in a note over here. I really am going to start just copying and pasting from a notepad file called boilerplate. But anyways. Alright, so I'm going to add my favorite preprocessor statements. # include, angle brace, standard IO.h, end brace. Hash include, std lib.h, end angle brace. Let's go ahead and disable that warning. I think we decided it wasn't necessary if you didn't compile it to C++, but I'm going to add it anyways. Pragma space warning parentheses, and inside the parentheses the word disable :4996. We're going to start using the safe version of scanf at a certain point, and we won't have to disable that anymore. Alright, int main. I am going to go ahead and throw in my system call, system parentheses quote pause, end quote in parentheses. And I think that's enough to save as boilerplate. So on my desktop, I'm going to say boilerplate.txt. I recommend you do the same thing, or else when you start making a program and I just copy and paste, I'm going to be 3 minutes ahead of you. Alrighty, let's declare a few variables and get their size. Short S1, int I1, no, I2. I said I wasn't going to use ones. Short S, int I, long capital L. Why capital L? Because lowercase l looks like a 1. Char C, bool B, excuse me, it's Boolean. We don't have a Boolean data type at all in C? Okay. And float F, double D, and most of these have unsigned variants. I think I lectured for a while on that. An unsigned variable is one that can be twice as large as the signed version of it, but it can't go negative. So if an int can go out to 2 billion, I forget the exact number, then an unsigned int can go up to 4 billion, but can't go negative. All right, let's print out some sizes. Print size of short equals %d, and we're going to be typing this in over and over, one for each one of these data types. So we're probably going to want to just copy and paste this. But there we go. Let's run it. This is enough to make sure that our code actually works. I'm going to rebuild the solution. Printf, excuse me, that was moronic. Alrighty, printf, build, rebuild solution. Getting an error. Now what? Oh, unreferenced. These are all warnings. Well, then what's the error? I don't have a return statement. Uninitialized local variable used. I don't care that it's uninitialized because all I'm doing is I'm getting the size of it. But fine. I'm going to add equals 0 to each one of these, except for the character.
Isn't it just going to print 0? So
You're right, because I actually wanted to print size of S. My mistake. Thank you for catching that. I would have gotten very frustrated when it printed out 0 as my size. Alright, so our S there needs to be size of parentheses S. That'll tell us how many bytes that variable occupies. And you probably notice I put more spaces than necessary. That's just for clarity of reading. You're not required to do that. Alrighty. Size of short is equal to 2. It'd have helped if I put a \n in there.
what's the pragma statement that you have again?
Just sec. Alright. That's my pragma. I don't have a scanf in here, and I think we established that if you create this program with s.c to begin with, you didn't have to have it, but I like it. Apparently I put a breakpoint in my code, which I didn't mean to. If you click on the border over here and it puts a red dot there, it means that when you run it in debug mode, it's going to stop on that line. Very useful, and we should spend some time playing with that, but that wasn't my goal. Alright, so size of short equals 2. A short is a 2-byte data type that can hold up to the maximum value of 65535. Now in the original C standards, none of these were defined. The only way they were defined is that it had to be greater than or equal to a short, and a long had to be greater than or equal to an int. You could have made them all the same size, right? That would have fit the requirements for a C compiler, but that'd be kind of stupid. Which is why it's stupid that Microsoft C uses long and int interchangeably. We're going to find out if that's the truth. I'm going to tack on a \n right there so that it'll go to the next line. Alright, I'm liking it. So I'm going to copy that line and paste it a few more times. 5 more times actually, so that I can print out I, L, C, F, and D. A fast way to highlight an entire line is to put your cursor at the beginning of it, hit shift down. That gets the entire line. Or if you just want to skip to the end of the line, you can hit the end key above your cursor and it'll zip to the end of the line. Alrighty, so size of S, I, capital L, lowercase c, lowercase f, lowercase d, and I'm going to modify the strings in the same way. That's no longer a size of a short on that line. That's the size of an int. This is the size of a long. That's the size of a character. That's the size of a float. And that's the size of a double. All right. And in C, as well as C++, an int and a long are the same type. So go up there and change that long to long. See if we can get an 8-byte integer using that. Actually, there's a space between them, believe it or not.
Really?
Okay. Good deal.
Yeah, I got it.
So all you're going to want to do now is change these words, because that one's an int, that one's a long, that one's a char. So change the word short to int, and long, char, stuff like that. Yeah, that looks good. That looks good.
What is it though?
A double is a floating point, but it's a double-wide floating point with more precision. A floating point number is one that has, a decimal point in it. The number of digits of precision of a float is like 8 digits. So if you have 3.99999, you could put about 7 or 8 .9s after it. Whereas if it's a double, you can do 3 point with 16 nines, no, more or less. And also the exponent size of a double is much larger than of a float. A float has got a limit of 30 or something like that. I don't have these numbers memorized. Whereas a double has an exponent size of like 300. So far larger numbers.
What's the point of having like 2 instead of just having one that's really big?
Why not use double all the time? Absolutely nothing wrong with using double all the time. And in Java, I'm in the habit of using double all the time because that's just the default data type. On the other hand, in Java, the default data type is int. So I got in the habit of using int all the time. Really, you could try to customize it so that you're not using a data type that's larger than the amount of data you want to store. And these aren't all the data types. There's byte, I believe, and there's uint for unsigned int, and so on. I don't remember seeing all those as keywords. Anyways, so where was I going with that? I would just use int all the time until you find a number that needs to be larger than 1 billion. Then switch over to using long. If you feel like using double all the time, just for the more precise, I feel good having more digits of precision. It's not like we're coding in an environment where you have to save every single dang byte. So there's nothing wrong with using a double. And there's also nothing wrong with using long all the way through. Well, long, except for the fact that it's kind of silly, the word is, but alrighty, long space long. Size of long space long.
So you're saying long is a specific keyword, or can you just keep adding longs to that?
Well, let's try that. Long's the max, actually. Okay.
Too long.
Now, Microsoft gives you very specific, and maybe it's an ANSI standard now, but there are precise data types that dictate how many bytes they use. So, int 16 underscore. So, underscore int 16. I'm going to call it I16, give it a clever name, equals 0. And I'm going to print out the size of that I16. Oh, and I'm also going to remove that third long. Did start the recorder, please tell me. Yay. Okay. So size of I underscore int 16. And then I16 is my variable name. So by doing this, we're specifying very specifically the size of the variable. Every 8 bits is a byte. So an int 16 is a 2-byte number, which is the same as a short. If we change that to int 32, it could, It's a 4-byte int, which is a normal int, which can hold a number up to the billions, 2 billion or less. And then if we made it int 64, that's an 8-byte number. So I think I'll do that as the final thing I do with my sizes. I'm going to change this int 16 to an int 64 and rename the variable I16 to I64 and make all those changes through the rest of my code. Oh, well, I had something dumb here. I said size of S. I never changed that to size of I64. Hopefully the results would have just said what I said, but all right. So size of an int 64 is the same as the size of a long. And I do believe those are standards now, part of ANSI C. I__ int 64. Or not. This thing seems to be indicating that it's not. Okay, yeah. There is a header file called inttypes.h, which you could use if __ int 16 or whatever weren't working. So if you were compiling in Unix or using GCC, when we start using GCC, we may see that happen. There wouldn't be anything wrong with just grabbing that and putting it at the top of our boilerplate.
I've been using GCC, and I mean, it hasn't, like, I've been kind of going through the book and
Yeah.
just doing stuff, so.
Yeah.
What is GCC?
It's the GNU C++ compiler. So it's very common on, this is the Microsoft compiler. GCC is not coded to be specific to Microsoft.
I used GCC the other day with just like a text pad on Linux. And
Right, right. You can create your files with any text editor. There are IDEs that will also use GCC. Eclipse is one, and that's one that I'm hoping we get to use when we go over to the room over there. All right, so I'm tacking on that int types just for fun into my boilerplate.
I had downloaded Eclipse and was trying to use it with GCC, and it wouldn't, like, default to using it.
Yeah, I need to make some instructions for that, and I'm sorry about that. I should publish them really quickly. My mistake, because you can configure it to use GCC, but if you choose the GCC option when you configure it, it doesn't work. At least it didn't work for me, but there's another option you can pick. Okay, so unsigned is its own keyword, so you could replace int with unsigned int. I believe uint maps to that as well. When I say map, I'm not sure where that occurs. We could always type something into Visual Studio. Oh, that's my old one. And then, so uint u. Nope, it doesn't know what that is. Okay, good. Never mind. There's probably a header file where it's defined. I was thinking about going somewhere with that and I decided not to. Okay, so we know what comments are. // later versions of C, anything written after C++ was invented is a single line comment. /*, these are forward slashes. This is a multi-line comment, that way you can put as much code in there as you want. Some people do really fancy headers like that, you know, slash and a whole bunch of asterisks, and then a whole bunch of asterisks followed by a final slash. Yeah, if you feel like marking code off with a really big heavy message, feel free.
I feel like that was overkill. Like, Ken Dewey has
Yeah, he's
intro
gonna
to
do
Java
that.
like that, and I was
Yeah.
like, this feels like such overkill.
Yeah. I admit I've done it. If you have a source file that's like 2,000 lines long, there's nothing wrong with breaking stuff out like that. But if it's a short program, then you could parse through it. Okay, so the keywords. auto defines a local variable as having a local lifetime. I thought we found out that auto did something different. Did we talk about the auto keyword last time, or am I thinking about C++? Yeah, we
No,
did.
we talked about
that.
Because you could do auto space I equals 3, and it figured out that it was an int.
Well, the reason I kind of think the description makes sense is saying like defines local variables having a local lifetime. Like, so once you move, I guess, further down into the code and redefine it, it just like its lifetime ends. Like it's just, I guess, local to that point in the program, and then because you can just put anything in it later on. So I just
Okay,
figured
let's
that's
play with that. I'm going to declare a variable int x equals
just
3, and then down here I'm going to declare x again and see if that's a compilation error. Yes, good. That's the way it ought to be. So if we do auto int and then we do auto int again, is that a compilation error?
Why would you auto int?
Well, you should take the int out.
Yeah, it shouldn't.
I'm going to take the int out, yeah.
And then, well, you're redefining it again. Take the auto out there.
Right, but then it's no different behaving. See,
Well,
when it
put
says...
put a different data type in there.
Oh, okay. Yeah, sure.
Take the auto away on the second one.
No way, that's not going to work. I mean, it won't give us a compilation error, but if we printed it out, it would just be a 3. I mean, it would just be a 10.
Try print it.
Print it out as a floating point number.
Zero.
All zeros. Let's print it out as a decimal number.
Because it defaults to int. That's why I did that too when I wrote a program.
Yeah.
So I just had to stop using auto because when I wanted I think one of them we asked for like a number and you wanted us to do something with it.
Right.
And it came out as a decimal at the end, but it started out as an integer. So I just had to.
Yeah. Why use auto in C? The keyword auto. When should it be used? Marked as a duplicate. Okay, great. Does it take us? I think when the type is a very well-known one, you can use auto. But when the type is not well-known, auto seems to reduce readability. Okay, so now see, that's the way that I thought it was defined. What they're saying here they're mentioning local lifetime. But every variable you create within braces is going to have a local lifetime. What does lifetime mean? Lifetime means that the variable disappears, its content disappears as soon as it hits the closing brace in which it was declared. So over here, all of these variables go bye-bye as soon as this closing brace is hit. And yeah, that makes sense. It's the end of the program. But if we did something like this, you could do this indiscriminately. You can create blocks of code. Like if I wanted to redefine D to be something else, for some reason I wanted an integer named D, I could do that. And then when I got back out of D, out of here, this would be gone, and we would still have this one, because this is defined in a different scope. Or not. I could be lying. X is an undefined. Yeah, okay. Well, why not print out D then? This should prove that the original value of D, which was 0, and let's give it something else other than 0, still takes place even though we temporarily created another variable. Okay, so 0.9. So you can use braces, to cordon off variable declarations. This variable is active only between those braces, and it masks, it hides the previous destination, the previous variable. So if we wanted to get a hold of this variable and do something with that 0.9, we couldn't, because we have a new variable that's hiding it, right? This one's kind of standing behind it. You can't access it anymore. So how useful is that? I don't know. Quite often, I will cordon off blocks of code with braces just to make sure that the variables disappear, so that later on I could, reuse those variable names for something else and not care about the types. But more commonly, you'll see that like as part of an if statement, right? If something is true, well, that's not. Yeah. If this is true, then go in here and do whatever's in there, and all the variables that you declare within those braces will be local to that chunk of code. I never used auto, really, even though it's been there since the beginning, and I doubt I'm going to start now. So break passes control out of the programming construct. If you remember your 1113, a programming construct is an if statement or a while loop or a switch, something like that, although you didn't do switches with Python. A case is used with a switch. If you've done Java or C++, you do know what these words mean, switch and case. Char, basic data type, is just a 1-byte data type. A const is an unmodifiable value. In Java it was called final. But say we like this d being 0.9 so much that we're going to make it a const. Later on, if I try to change it, now that it's been marked as a const, it's not, the compiler catches it. It says the expression must be a modifiable L value. That doesn't make the program more secure. It's not like that data is made more safe somehow by making it constant. If you have a buffer overrun and something is changing, the data, it'll ignore the fact that it's const. If you go in and you sector edit the program with a hex editor and you find the values, and you change it to something else, it'll change it. It just stops the compiler from, it tries to catch code that's changing it. Kind of a gentleman's agreement between you and the compiler saying, please don't let me change that. It's important to me that that stays the same. Default is also used with switch. There are several statements here that are all used with switch. Case, default. A do is a do while loop, which you did not use in Python. It just does flat out does not have that word, but you did do in Java. And if you never took either one of those, then great, it's brand new to you. Double wide floating point. Else, that's when you have an if, and then you can have an else. And quite commonly, when we're retyping things in and we're enunciating, we're verbalizing it, we'll say if, then. There is no then keyword. What if we wanted a then keyword? This is kind of silly, but you could come up here and do # define then. That's enough. So that down here, if I wanted to, I could do if parentheses f is equal to 0, then. Why would you do that? I don't know. But you could. Your goal is really not to write your own language that is impossible for other people to follow. But one thing that people do commonly do is define true and false as 1 and 0, so that you can then assign those to int variables. I thought that was a thing of the past, but I just typed bool and boolean, and those weren't supported types. Well, what do you know? It's popping it up right there. It's got to be a supported type. Why was it?
Because we're using the C++ project, maybe?
It must be a C++ keyword. Okay. So, what you could do, this is getting kind of silly, but you could define bool as the word byte. Byte is acceptable, right? We can come down here and do byte. B. Oh, for Pete's sake. Okay, short. Is short or a character? We could define it as a character. Okay. And then you could have pound define true as being 1. You could have pound define false being 0. And so if you wanted to make a Boolean variable at that point, bool, okay is equal to true. And then later on, you could have an if statement based on that. If okay, then do something. print hello, like that.
Okay, why wouldn't we define bool as an int?
No, why don't we just?
You could make it an int, you can make it any numeric data type.
Okay.
It's just it has to be non-zero. The way the if statement ultimately works is whatever is in the parentheses, if it evaluates to 0, it's treated as false. If it evaluates to non-zero, it's treated as true. So I defined false as 0 so that if we ever defined OK as false, it wouldn't go in here.
Okay.
Anything else would.
Why don't we just define print as printf?
I'm sorry, pardon me?
I said, why don't we just define print as printf?
Well, you could. This print statement's not wrong, though, right? I hope so.
Well, if you didn't write printf.
Oh, we really don't have a printf? Yeah. Okay, I kind of like that idea. Define print as printf. I'm digging that.
I'm digging that.
All right. Okay. Yeah. Okay. What if we need? Well, I guess I'll continue with the.
Like, what if you only knew Python and then you just...
And you make this look as much like Python as possible. Well, if it's for your own purposes, great. If you're giving the code to somebody else, they'll look at you cross-eyed.
Sounds simpler,
That'd be great. I'm sure it's out there somewhere.
yeah, somebody probably wrote it.
Python and C.
Now, unions are very, very odd, and yet I know that people use them. What it does is you can create a data type that could be a float or it could be an int. Why not? You can, it can store either type, but once you store one type in it, you better not treat it as the other. Now, ints and floats are so close to being compatible that that wouldn't be a problem. But just like when you define a class in a language that supports object-oriented programming, you can define a struct, and a struct can have several different data members. You might say that this struct has 3 bytes in it, and then you might also say that this struct, the same struct, could have 2 longs, or that it is composed of 2 longs, and you could treat it one way or the other. It's really fairly odd. I hope the book gives a better definition than the one that I just said. But that's what union does, is it creates a data type that can be used, groups variables to occupy the same data space. And people will do things like that sometimes because they want to be able to change each individual part of the data. If you say, I have a long, and it's the same as 4 shorts, then you can access each short differently, which would modify part of the long. Alrighty. So the statement terminator, the semicolon. Pretty much every C statement ends in a semicolon. There are some exceptions. Comments. Yeah, you could end a comment with a semicolon, but you don't have to. Preprocessor directives. Well, the preprocessor is really not part of the C language, so that kind of makes sense. The begin and end program block identifiers. You don't have to put a semicolon after the open brace. In fact, you better not. Probably wouldn't break it. And then after the close brace. Function definitions, whenever you define a function like we did with our main functions, you absolutely do not put a comma there. It's a semicolon there, or else it just flat out is not going to compile. And so my last rule at the bottom was anywhere there's an open brace, do not put a colon on the line above it. I think that's a truism. Even though I never see anybody else define it like that, that's pretty much my way of defining it. All right, so escape sequences. \n goes to a new line. \t goes to the next tab. Why might you want to use that? If you want to format your data in some nice format. What do I mean by that? I'm going to come down here and I'm going to make a printf statement that prints some numbers out, like 1, 2, and 3. \n at the end of it. And then I'm going to make one that prints out 10, all I did is copy and paste it, 20 and 30. Then I'm going to make one that says 100, 200, 300. And that's about enough to prove the point. I'm not going to make them go up to the thousands and the millions and stuff like that. But when we print it out, right, they're not lined up. Not pretty. There might be times when we want things to be lined up for ease of use. Like if I do a dir from the command prompt, dir, and I think it's /a. Okay, there's some really horrible file names in here that are totally messing it up. But you can see that it lined them up in columns, right? To make it easy. And it didn't matter how long the file name was. Well, it put the file name last. It kind of cheated in order to make this work. But same idea. I want this stuff to be lined up, so I'm going to put tabs here. I'm going to put a \t there and a \t there before the 2. In fact, before the 2 on every line and before the 3 on every line. And so when we run it, 1, 2, 3, 10, 20, 30, 100, 200, 300. That's kind of the poor man's way of formatting data, because you could do the same thing with printf. You could specify the width that you wanted to fill in. I think I'm going to go ahead and play with that. Printf %8d, 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 \n, and then I'm going to pass in the numbers 1,000, 2,000, and 3,000 into my print statement. And if I've guessed correctly, I think they will still line up with the rest of them. No, because these are right justified, not left justified. I can change the printf statement so that they are left justified, though, by using the hyphen after the % sign. So what does this mean, %8d? This means this is a special formatting. It's a placeholder. This is how many columns, how many spaces I want that number to occupy, and this is the data type. But if I prefix a number of spaces with a minus sign, it'll be left justified rather than right.
Last year when I went to Kmart before it closed down, their whole point of sale system was in like a console application still.
Oh, really?
Yeah, I don't understand how I mean, it looked like really neat. I mean,
but it was working, and so they never changed it. Yeah.
2017.
Yeah.
At the point in time.
Yeah. Okay, so you saw here that this is a more precise way of formatting the widths. And why would I do that? Because once a number gets too large to fit in a single tab, like what if this value was more than 8 characters long? Right, that's 3 characters long, 4, 5, 6, 7, 8, 9. It's going to mess my tabs up. Right, it pushed that one over to the next tab. And if I had formatted them with a printf statement, I could say, oh, I really need everything to be 10 characters wide. So I could change, right? I could remap where those break, where you can't do that with tab, right? You can't remap where the tabs are going to fall. So printf using format specifiers is a better way, but looks longer, looks harder to type. If you're doing something cheap and dirty, you may as well just use \t. There's an advantage to writing code quickly sometimes rather than, specifying, going too much into trying to get it. So down here, no, I guess it's actually in the homework document, not this one. Well, I'll open up the homework document so we can take a peek at it. Okay, these homework problems are straight from the book. That doesn't mean I want you to Google the book and find some solution guide to it. Although if you ever find a set of PowerPoints for the book, I'd appreciate them.
I already did.
And did you find any?
No.
All right, so One of the questions is create a calendar program that prints out like this. All you're going to do is use /t's, right? You're going to print sun/t, mon/t, 2/t, wed, Thursday, Friday, Saturday. And just make it match our month, right? You know, so our month is starting on 1, right, with 1 on Friday. So just modify it so that it's that. That's one of the problems. Another one is to print a diamond as shown here. Don't go nuts and try to write it with for loops and while loops and stuff like that. Just make it simple. Okay, if you feel really ambitious and you feel like doing it with for loops and while loops, you could do that. But that'd be an entirely different problem. Create a program that prints your name. Well, that's challenging. Not. Create a program that uses the escape sequence \quote to print your favorite quote. Like, if Worf from Star Trek wants to lose weight, today is a good day to diet. All right. How would we print that? Well, the problem is that if we do something like this, well, heck, I'll put it in our code. Printf quote, and then I want to start my quote. Tomorrow is a good day to diet. That's not going to work. That's a syntax error. Why? Because that's an open quote and then that's a closed quote. And so the rest of this is not treated, you know, as a token within a string. So what you have to do is you prefix the offending quotes with backslashes to make them escape characters, and that will print out a double quote. I didn't put a /n in there, so it doesn't look pretty, but you get the idea. If you want to print out single quotes, you can do that. Now, why do that? Because single quotes will work anyways, right? Because you're not mixing doubles and single quotes. So I could run it like that, but then I could also write it in such a way that I didn't make them escape characters. The one time you have to use that escape character is if you're doing something like that. Character AP for apostrophe is equal to, when you define a character, you have to use single quotes, and this wouldn't work, right? That won't work. So that will, because that gets translated as to being an apostrophe. So then create the program to print the following output: cit2093 home administrator. Well, there's our problem. Is let's make something that'll program that'll write that out. Printf \cit20 \home \administrator. Oh, and my \n at the bottom, at the back. I'm putting \n at the end of each one of these strings just to make them easier to read. All right. That just about came out better than I was expecting. But obviously the backslashes aren't working. And some of it didn't get messed up. /h didn't break, but /a did. What if it was something like cit20-new \temp \administrator? We're going to see that it's far more broken than before, because /n is going to be treated as a new line and /t is going to be treated as a tab. That makes me wonder what /a really does. Anyway, cit20, and then it went to the next line, ew, and then it had a tab in there, imp, and then it messed up our a. So how do you fix that? You use the double slash, the double backslash. Not the double backslash. I'm spacing out. You use percent signs. % means insert a slash in your output. Like that. What do you know? It still didn't work.
Yeah, I thought it was double tap too.
It is double slash?
Yeah.
Okay, cool. My mistake. That's what I said. I should have trusted my instincts. Alrighty.
So the percent sign didn't show up.
Yeah, it didn't show up, but it didn't get treated right either. What I was expecting, and what some of the other languages will do, is if it sees a percent sign and it's not one of the matching languages, one of the exact matching escape sequences supported by that language, printf will throw an error, right? It'll crash. In this one, it's not crashing. It's just sometimes ignoring the character. /A, it was ignoring the A, but /C, it wasn't ignoring the C. So I would say that the behavior is kind of undefined, you know, if you're using single slashes. If it is an existing escape sequence like /n, it's going to treat it as valid. I mean, it's going to do what we expect. That makes me think that /A is an escape sequence that I'm just not aware of. Maybe it's right there in the book and I haven't spotted it. /A escape sequence. If I could type better, I would. Oh, beep, alert. If we were using a printer-based system, that actually rang the bell. I remember doing that actually in the old days of DOS. You could write a program that would sit there and beep until somebody went insane. All right. Okay, so here's Wikipedia's list of all the characters. Why was I putting percent signs in there?
I don't know.
Neither do I. When did I miss?
Foreshadowing percent.
No, it's why in the world was I suddenly switching to percent signs? Percent signs have a very specific meaning. They mean placeholders. They're not escape sequences. Escape sequences are \t. Placeholders in your formatted print statements are the percent signs. And my brain got cross-wired and I said the other one. Double quotes, single quotes. V is a vertical tab. I'm kind of curious about that one, but I'm not going to bother. Okay. You can also specify hexadecimal values using the \. Printf \x34. No, I know what a 20 is. It's a space. No. Let's do a 40. And then a \n. That'll print out let's prove what that'll print out. The @ sign. If I Google up ASCIItable.com and I go look up the ASCII value for hexadecimal 40, we will see that it is indeed the @ symbol. So if I changed it to 41, it would print out an A. So it's just a way of printing out the ASCII character that matches the hexadecimal value specified. So we could make it print out ABC. /x42 is a B, /x43 is a C. That'll print out ABC. And I remember that we skipped the ASCII lecture when I was typing in numbers and stuff like doing binary, so we'll get back to that. We did? Okay, cool. We skipped something. I'll have to go back and look. All right. So those are examples of escape sequences. You can use \n more than once. This would print 3 lines, right? Line 1, line 2, line 3. Printf doesn't go to the next line automatically, so you can use several print statements and it'll keep printing on the same line until it finds a /n. Just like if in Java you did not have a print ln statement and you had to use /n everywhere you want to go to the next line. All right, so debugging. I'm going to skip this one. Well, we can show it. I'm not going to type it in though. This is an example of a format bug. The format issue can be fixed by using /n and /, So what we would have to do is we would have to put /n's everywhere. And also, when we try to print this out, what's that going to do? It's going to go to the next line. So we would do that. And when we printed this out, what's it going to turn that into? A single slash, right? So we would actually want to do that in order to make a single slash. A double slash, excuse me, right. Okay, now debugging. The book tells us to do this, and I hadn't really keyed in on it very much. But if you're doing debug print statements, it's not a bad idea to immediately flush them to the screen to make sure that they're not just hanging out waiting to be written to the screen. So you can use printf, entering my function, and then you can flush it to make sure it goes immediately to the screen. Let's just tack that onto one of our printfs. Down here at the last one. Printf, yo, this is a debug. \n, end quote, in parentheses. And then I'm going to do flush, parentheses, stdio. Nope, that didn't work. Pop back over there. std out, my mistake. Now that should work, and we're not going to see any difference than its behavior in any other way. But if you had multiple programs in multiple threads of execution working in the same place, and you wanted your print statements to all be, written one for their own line, then yeah, flushing it as soon as it gets sent out to the buffer is not a bad idea. There is a version of printf called fprintf. And you could do this. Standard out just means send it to the console. But there's another one called stderr. We could print error messages using stderr. They're not going to look different to us. So why are there two versions? Let's prove that to be the case before I lecture too much on that. Okay, but if we pipe this thing's output to a file, you may have seen that before. It's a fairly important concept. I shouldn't use the word pipe, that's a very specific thing. If we redirect it to a file, like if I do this, dir, and save it to t.txt. Well, if I type in dir, it prints the output to the screen. But if I type in dir greater than t.txt, it saves it to the file, t.txt. It redirects it to the file, which I can open up with Notepad or something, type.txt. However, if you're printing to standard error, it can't be redirected. So if I had a program and we redirected this output, everything here would be saved to a file except this line. This is debug. That would still be displayed on the console, even though the rest of it would be saved in the file. Now, why would you want to do that? What if you have some program that's generating thousands of lines of output? You could save them to a file, but it'd also be cool if you were sitting there watching, and if an error occurred, rather than go and look at that file, if you sent it to standard error so that you'd spot it right away. There's something wrong with this program. Okay, so the last thing I wanted to cover today is the idea of a debug print statement. You've probably run into a situation where something is crashing or you can't figure out what's doing, and you start adding print statements all through your code trying to figure out what's wrong. And then you get your code working and you comment all those things out, right? Or you delete them. And then later on you wish you had them again. Here's something we could do. #define dbg as being printf. And so here I could do dbg parentheses, hi, this is a debug statement, \n. And when I ran it, this is going to be preprocessor replaced with the word printf. And then when I'm ready to ship my code, I'm going to comment that out. And I'm going to write a new one, #define debug, as meaning that. Hope that works. Okay. I'm going to come up with a better variant this next time, because it seems to be printing. No, it's skipping. Did it skip it last time and I just didn't notice?
I couldn't tell.
Let's skip it. Let's do this. And then when it runs, is it going to print out this is a debug statement? We'll find out. It did not. So what happens if we swap these two #defines? Is it going to print this is a debug statement? Yes, it did. Okay, good. That was my first instinct. I was disappointed when I thought it didn't work. It actually did. Now we could redefine these even better so that we had #define debug true and then #define debug false, and then it redid the rest of these. But the idea is that we could stick debug statements in there and then we can disable them, right, through the preprocessor. And in the past I found that to be a good idea. So that I could litter my code with debug statements, and then when I want them all to go away, I just go and change my preprocessor.
So that second preprocessor, does it make that whole line a comment?
Yes.
Okay.
Right.
So the preprocessor doesn't ignore comments.
Correct. The preprocessor is not ignoring the comment, which is what I was worried about. So when we hit that debug, what happens is it gets replaced with that.
Gotcha.
Right. Now before I figured that out, I did it the way that I was just showing you, where you have a bad if statement, right? If 0, then
So
do
it
printf.
false.
Yeah, so that, and that would work as well. All right, I think that's about enough. I think we've hit the end of the slides. We've hit the end of the chapter. Please read the chapter if you haven't already. And do the homework assignments that have been uploaded. Are there any questions over what we covered? Am I ending too early? What time are we supposed to end?
7.
7?
Got 7 minutes.
All right. Well, dang, I'm missing 10 whole minutes of our time. Why don't we throw in a while loop into our code?
Did your sound work? I just wanted to see if that /A, that beeping noise, can you do it?
Try it on your laptop with your volume enabled. See if it beeps.
So we got like beep at the end of the line, like after this line.
Right. That's what the /A character is supposed to do. Is it's supposed to ring the buzzer in your computer, which we don't have buzzers anymore, but we have sound cards that beep, so it might still work. I'd have to enable speakers and stuff like that on mine. I think it's okay if we end right here.
So it's pretty much just if I print /A, right? Just
Right.
Make it beep. Okay.
Right. Correct. So let's make a Dropbox for ourselves. And we're going to stop the recorder. That was an informative name. All right.
Oh no, I was just enabling my sound.
I was saying it's working? Cool. All right, if you refresh your Dropbox, you'll see Dropbox D, so please go ahead and upload into it. If you miss a day, remember all you have to do is watch the video. I'd recommend following along and typing everything in. At the very least, I want you to watch the video and then upload a note saying that you did, right? And then it's on you as to whether you actually gained enough knowledge from that as well. But, you know, if you're on a computer that doesn't work, you know, you want to watch it on your phone, you think that's good enough, then you can do it that way as well.
Yep, it works.
Neat. Okay, we can do /A's and annoy people. Write a program that beeps once every 37 minutes and that runs in the background without a user interface. And then every once in a while, somebody's computer will beep and they'll have no idea why.
I think we get hacked, to be honest.
Yeah. All right, so go ahead and upload your document to that Dropbox, and I will see y'all Wednesday.
Oh, can you make a Dropbox for the homework?
I will, that's correct. No, there's not.
Oh, yeah.
Uploading these every day.
Yes, please. And if you haven't been, just upload a note saying you attended that day, okay?
Okay.
Yeah.
Yep, it works.
That's-
Yay.
That'd be really fun. Create some Morse code with that, you know?
Should have that except like for Windows XP, like one.
Is there a reason why it slowed down?
Just 10 hours.
I don't know.
Make it part of your CPU thing. What is that one
Okay.
Why is it speeding up and slowing down? You'd think that it would be just like a rapid, you know, machine gun of beeps.
is that the process?
Okay, I've stopped it. Why are you still? Oh god. To the task manager.
Oh, that would be hilarious. It just kept being.
I don't know. I closed it. Is there a reason that Note or Visual Studio Code is like so much harder to set up than like Notepad? Like, I mean, like adding extensions to run and compile and stuff is a lot easier in Notepad than like Visual Studio because it uses like JSON files for like configuration, and I don't understand.
You mean TextPad?
Huh?
You mean TextPad?
Notepad++.
Oh,
It's a text editor, yeah.
Oh, I'm not familiar with Notepad++. It's just that Visual Studio is a huge, huge, huge
Notepad++, you can do like
application.
text editor, too. It has like built-in text editors.
Oh yeah.